Now, in our previous video or lesson, we have learned on and begin. In our previous lesson, we learned on angles of a line. So that means when we have a straight line with the equation of y is equals to mx plus c, the angle it makes with the x-axis can be derived using tan theta is equals to m. So theta will be arctan dm, where the m is the gradient or slope. Now, what if we have two lines? Let's say we have y is equals to m1x plus c1. Similarly, we have y, okay, let's say y is equals to m2x plus c2. And the question asks here, what is the angle between these two lines? Remember, we are still on trigonometry. And now, if we use tan theta is equals to m in this case, turning the pencil to red. But in this case, we'll be using tan theta is equals to the modulus of m2 minus m1 divided by 1 minus m1 m2. Now we could have derived this, but we don't want to have too many concepts on our head. So tan theta is equals to m2 minus m1 divided by m1 minus, it should be plus m1, 1 plus m1 m2. So let's take an example. We are asked to find the angle between the lines y is equals to 2x plus 3 and y is equals to 0.5x plus 1. So all we just have to do is to compare this. Y is equals to m1x plus c1 and y is equals to m2x plus c2. Now in this case, m1 is equals to what? 2, and in this case, m2 is equals to 0.5. Now we'll just apply our formula, and our formula says tan theta is equals to tan theta is equals to the modulus of x2 minus m1 divided by 1 minus plus m1 m2. So let's make our substitution. So with this, we'll have tan theta is equals to m2, which is 0.5 minus 2 divided by 1 plus m1, 2 multiplied by 0.5. And this will give us minus 1.5 divided by 1 plus 1, because 2 multiplied by 0.5 is equals to 1. So in essence, we have tan theta is equals to minus 1.5 divided by 2, which is equals to minus 0.75. Since the modulus will neglect the sign, then we'll have that tan theta is equals to 0.75. So with this, we can easily evaluate the theta. The theta is arctan 0.75. And using our calculator, the arctan of 0.75 is approximately 36.87 degrees. So we apply the formula that tan theta is equals to m2 minus m1 divided by 1 plus m1 m2. Let's take another example on this. We're asked to find the angle between the line y is equals to 4x minus 2 and y is equals to minus 0.5x plus 6. So all we just have to do is to compare it to give us y is equals to m1x minus c1. This is the equation of the first line. And also we'll have y is equals to m2x minus c2, which is the equation of the second line. And we'll have m1 to be equals to 4, and likewise we have m2 to be equals to minus 0.5. So with this, now you can pause the video and let's see if you can solve the angle between the two lines. Alright, I believe you paused the video, so let's proceed now. Let's recall the formula that we are using. The formula says tan theta is equals to the modulus of m2 minus m1 divided by 1 plus m1 m2. So let's apply the formula. Making the substitution of m2, we can simply say that tan theta m2 is equals to minus 0.5, m1 is equals to 4, and we have 1 plus minus 0.5 multiplied by 4. So this would give us minus 4.5 divided by 1 minus 0.5. Okay, let's revise this. Minus 0.5 multiplied by 4 would give us 2. That's plus minus 2. So simplifying this further, we will have minus 4.5 divided by 1 minus 2. So therefore we have tan theta is equals to minus 4.5 divided by minus 1, and moving forward we'll have this to give us 4.5. The modulus of 4.5 is equals to 4.5. So with this we can just take the arctan to get 4.5 to get the angle theta. So arctan 4.5 is, using our calculator, we'll have it to give us theta to be about 77.47 degrees. Now the question now is, we want to move on. I want to find what about when we have parallel lines. That means we have y is equals to m1x plus c1, likewise y is equals to m2x plus c2. And now we want to consider parallel lines. And in parallel lines, m1 is equals to what? m2. m1 is equals to m2. So now let's take a look at the formula that we apply. So in parallel lines, we know that tan theta, which is the formula for angle between two lines, is equals to m2 minus m1 divided by 1 plus m2 or m1 m2. Now we are making the condition that m1 is equals to m2. So if m1 is equals to m2, so we can just substitute m2 to be equals to m1, or m1 is equals to m2 as the case may be. So this will be m1 minus m1 divided by 1 plus m1 m1. So with this we'll have 0 divided by 1 plus m1 squared. Now we know that 0 divided by 1 is equals to 0. Likewise 0 divided by infinity is equals to 0. So with that being said, we can now say that tan theta is equals to 0. So taking the inverse of this, tan theta is equals to 0, we'll have this to give us inverse of 0, which is equals to 0 degrees. So when we have parallel lines, angle theta between the two lines is equals to 0 degrees. Let's take an example. Let's give we have y is equals to 3x plus 5, and likewise y is equals to 3x minus 7. So let's compare. So it's to y m1x plus c1, and let's compare also this to be m2x plus c2. So we can see now that m1 is equals to 3, m2 is equals to 3, m1 is equals to 3, m2 is equals to 3. So with this we can see that m1 is equals to what? m2, just as we have here. Now let's apply the formula that we have, that tan theta is equals to the modulus of m2 minus m1 divided by 1 plus m1 m2. So therefore 3 minus 3 divided by 1 plus 3 multiplied by 3. and this will give us 0 divided by 1 plus 9, which is the modulus of 0 divided by 10. 0 divided by 10 is 0, and the modulus of 0 is equals to 0. So with that, we have tan theta to be equals to 0, and theta will be arctan of 0 according to inverse trigonometric function, which is equals to 0 degrees, and similar to what we have here. Now, what if we now have perpendicular lines? If we have perpendicular lines, okay, so let's give a question for perpendicularity. So that means we have a line. Let's say y is equals to m1x plus c1, and likewise another line, y is equals to m2x plus c2. Now, according to the name itself, if they are perpendicular, then the angle between them should be simply 90 degrees. But then we want to prove it, right? So let's prove it together. Moreover, there is no need to actually prove, where we can just apply it. But then let's do it together. Let's take a question. But before we take a question, let's have a check for lines that are perpendicular. Perpendicular lines. Okay. The check of this perpendicular line is simple. It says that the product of the two gradients is equals to -1. Remember, the check here is simple. That's m1 is equals to what? m2. That's for parallel lines. But then for perpendicular lines, m1, m2 is equals to -1. So let's have a question. We have y is equals to 2x plus 1, and likewise y is equals to -1 over 2x plus 3. If you compare this to m1x plus c, and also compare this to m2x plus c2, then we'll have that m1 is equals to 2, and also m2 is equals to -1 over 2. So with this, we can check for perpendicularity such that m1, m2 is equals to 2, since m1 is equals to 2, and m2 is equals to -1 over 2. And this will give us -1. So with this, we know that the lines are perpendicular. So we don't really need to solve further. I will just know that the angle theta here is equals to 90 degrees. But however, if we want to solve further using the expression that tan theta is equals to m1, or let's say m2 minus m1 divided by 1 minus m1 plus m2, m1, m2. Then if you apply this formula, then we'll have tan theta is equals to m2 is equals to -1 over 2, m1 is equals to 2, and we'll have 1 plus m1, m2, which is 2 multiplied by -1 over 2. So therefore, our numerator will be -1 over 2 minus 2, and this will give us -5 over 2, and this will give us 1 plus 2 multiplied by -1 over 2 is -1, and we'll have -2.5 divided by 1 minus 1. This will give us 1 minus 1, which is equals to 0. Now, anything divided by 0 is undefined. So now we have tan theta to be undefined. And if you recall from special angles, that whenever we have tan theta to be undefined, then theta is equals to 90 degrees, which is equivalent to what we have here. So now we have come to the end of this expression, and let's take a summary. And in the summary, we will have angles between two non-perpendicular lines. When we have two non-perpendicular lines, we will have y is equals to m1x plus c1, and likewise y is equals to m2x plus c2. Then tan theta is equals to modulus of m2 minus m1 divided by 1 plus m1 m2. However, when we have parallel lines, it's simple. That means we are saying y is equals to m1x plus c1, and also y is equals to, just as we have here. So in parallel lines, we will have that m1 is equals to m2, and with that theta is equals to 0 degrees. And in perpendicular lines, m1 m2 is equals to -1, and the angle between these two lines is 90 degrees.